Lesson 22, Energy. And we will also be taking a more specific look at what we call potential energy. So our objectives, first, to define energy. Then, we want to be able to define potential energy. You will also want to be able to analyze situations involving potential energy, as well as to determine an object's gravitational potential energy. So let's start with the definition of energy. Energy is the capacity or the ability to do work. Remember, when we took a look at work, we said work is when a force is applied through a distance. In this case, in order for a force to be applied to an object and move it through a distance, it requires energy. So in other words, for work to occur, we need energy. The easiest way to measure energy is to measure the amount of work that it does. And that's going to be how we're going to be looking at potential energy a little bit later on. So if we know that something uses 5 joules of energy, we know that it did 5 joules of work. It's as simple as that. Some important facts about work and energy. One you may have already noticed is that energy and work have the same units, joules. The second is that work is the means by which energy changes form. So when energy changes from one form to another, it's brought about by work. And lastly, energy can always be categorized into one of 2 major categories, either potential energy or kinetic energy. So the rest of this lesson, we will be talking about potential energy. Potential energy is stored energy. It's energy that's just sitting there waiting to be used, waiting to do work. The symbol that we will use to represent potential energy is a PE for potential energy. And as we just said previously, the unit is joules. The type of potential energy that we are going to focus on deals with the force that we've studied the most, gravitational potential energy. We're going to go through an explanation before you get a definition for gravitational potential energy. If you remember in the video that you watched, Bill Nye lifted a bucket of water, and he said that required work. So if an object is lifted above the surface of the earth, it requires work. So as the water was sitting in the tank above his head, he then opened a valve, and when he opened the valve, the water was able to flow through and do work. So we got that work back. So the work used to lift the object is stored by its position because gravity can do work on the object when it pulls it back down to the surface. Gravity did work on the water, pulling it down through the hose, making it turn the dial. So the definition for gravitational potential energy is stored energy because it's potential energy, but it's stored energy in an object because of its position, because it is located above the surface of the earth and gravity can do work on it. The formula says PE equals mgh, and these are all letters that you should be familiar with by now. M is the mass of the object in kilograms, G is gravity for the earth, 9.8 newtons per kilogram, and H is the height of the object above the surface of the earth. You will want to put this formula on your formula card under mechanics, labeling it gravitational potential energy. Let's take a look at our example. It says a 2.5 kilogram brick is lifted to a height of 5 meters. What is its potential energy? So we note first that we are looking for potential energy, PE. And our formula for potential energy says we need mass times gravity times height. So the mass of the object is 2.5 kilograms. Gravity, as usual, isn't given in the problem. It's understood that we need it. But gravity is still 9.8 newtons per kilogram for the Earth. H is the height. So it says that we're at a height of 5 meters. Now we can substitute our values in. We multiply and we get an answer of 122.5. In looking at our units, we notice that we have kilograms in the numerator with the mass and kilograms in the denominator with gravity, so they'll cancel, and we end up with a Newton times a meter, which we know is a joule, which is what we expect for energy. Energy should be measured in joules.